Our subject is Electronic Circuits 2. In this introduction class, we are trying to learn some basics. First, we have to know what is an electric signal, because we deal with the wave shaping circuits. So, what is an electric signal? How many types of electrical signals we have? We have two types of the electrical signals. One is voltage signal, second one is current signal. See, when I am trying to see this chalk piece, sunlight is falling on this chalk piece. After that, this light is reflecting to my eye. Similarly, when I am seeing an object, when you are seeing the board, when you are seeing what I am writing on the board, sunlight is falling on the board and this light is reflecting to you. Your entire body is receiving that light, but only your eye is capable of converting that light into electrical signal. Your hair is receiving the light, your ear is receiving the light, your hand is receiving the light, but only your eyes are capable of converting that light signal to electrical signal. So after converting that to electrical signal, this electrical signal should be sent to the brain. In the brain, we have 5 cortexes. One is for receiving the audio signal, that's what we call as the audio cortex. And one is for receiving the light signal. And next one is touch. And next one is smell. And next one is taste. Audio signal. You are listening to my voice. That does not mean your ears are, my voice is reaching only to your ears. Sound waves, your eyes are also receiving the sound waves. Your hand is also receiving the sound waves. Even your chair, even the bench you are sitting is receiving my voice. Even the books you are holding, even this chalk piece is receiving my sound. But they are not capable of converting these sound waves to electrical signal. Who is doing that? Our ear, both ears. They are capable of converting this sound signal to electrical signal. The converted electrical signal will be sent to audio cortex in the brain. The operation of the ear is to convert the sound signal to electrical signal. The operation of the eye is to convert the light signal to electrical signal. Similarly, sometimes you may smell some jasmine smell. At that time, your nose is saying, here some jasmine flower is there. It is converting that smell signal to electrical signal. And now in this winter, you are saying, this is very much cold. When you touch some heat substance, you are saying, this is very much heat. This skin, when I am holding the chalk piece, I am holding something, my skin is telling. So it is converting this touch information to electrical signal. What a good touch sensor we have. What a good sensor we have. What a good camera we have. It is capable of converting to electrical signal. What a good microphone we have. Our ears, they are capable of converting our sound signal to electrical signal. All these inventions came from these senses only. By seeing your eyes, camera came. It is the replication of the camera. By seeing your ears, microphone came, touch sensor, and finally taste. You are tasting some interesting sweet. Your tongue is converting that taste signal to electrical signal. Finally, we are sending that electrical signal to that particular cortex. So whether we are seeing or listening or smelling or tasting, all these signals are being converted to electrical signals. Our brain does not know whether this is a light signal or whether this is an audio signal or whether this is a touch signal or whether this is a smell signal. Even if you eat some sweet which you like or do not like, it will send only electrical signal. Even when I speak in English or Telugu or Hindi, only the ear can convert into electrical signal. It is your brain to understand that electrical signal. So when we are moving in this world, whatever the action we are performing in the daily lives, you are already converting all these signals to electrical signals because our brain can understand only electrical signal. So finally we are converting the light signal to electrical signal, touch signal to electrical signal. So there are 5 cortexes are there. These 5 cortexes are there in our brain to receive these signals. After receiving these signals, our brain will process. What is this? Then the memory will come. In the memory we are saying, okay, this is chalk piece. If I have never seen this, then my brain cannot give any input to me. So I cannot tell what is the name of this. If you say a new substance, if you say a new person, if I ask what is his name, you cannot tell because his information is not stored in your brain. Similarly, when you are listening to some voice, oh, this is the voice of my father, this is the voice of my mother, this is the voice of my brother or sister. How you are saying? Because that voice information, equivalent electrical signal is stored in the brain. Similarly, when you are eating some sweet, closing your eyes, you can tell this is this sweet, this is gulab jam, this is the rasagulla. How you are saying? Because that information is already stored in your brain. Similarly, when you are smelling some jasmine smell, you can tell this is the jasmine because that was already stored in your brain. So, in the daily life, we are receiving many signals. These are the physical signals. See, this is light. This is audio signal, sound signal. These many physical signals we are converting into electrical signal without knowing. Whether we know it or whether we do not know it, but our senses are doing that activity. So signal processing, electronic circuits too, whatever we are learning, we are giving the name. The wave shaping, electrical signal, when I asked voltage and current signal, our entire system is working with that electrical signal. Neurons, they are processing the electrical signal. If I have to move my hand, my brain has to give the electrical signal to my hand. Otherwise, my hand will not move. I can say, move my hand, move my hand, move my hand. 3 commands, but my hand will not move. I can say, okay Google, move my hand, but my hand will not move. Because even though I am saying that command should come from brain, there is no need to say now, move, but my hand is moving because the electrical signal came. You see, sometimes some persons will get fits. They will get the more electrical signal towards the hand. At that time, to nullify that more electrical signal, you keep some conductor in their hands. Okay, then they will come out of that fits. You have seen, I think, these circumstances at least in movies, but not in real life at least. Sometimes if you do not receive the electrical signal, then we say that particular part is paralyzed. Means that a person cannot move the hand. If a person is in coma, that brain, even though you are listening to someone and you wanted to move the hand, but you cannot move because the electrical signal is not going to your hand. So if you want to move a single finger or simple hand, or even if you want to talk, or even if I want to rotate this chalk piece, then electrical signal is required. Brain has to send the electrical signal, whether you know it or you do not know it. Your brain is processing with that electrical signal. Okay? These electrical signals are two types. One is voltage and second one is current. Now we will try to understand, when I am speaking, I want to represent that electrical signal on the screen, on the CRO. Is it possible? Can I see on CRO? In order to see on CRO, I have to convert that audio signal to voice signal to electrical signal. I can convert to either voltage signal or current signal. This voltage or current signal I can see on CRO. Sir, you are speaking, this is a sound signal, that is an electrical signal. How both are same, sir? 1 gram of gold I am taking. So 1 gram, 6,000 rupees. This 1 gram gold I am representing with the 6,000 rupees. 2 grams gold means 12,000 rupees. Now I am saying both the 6,000 and gold are same. But in reality, both are not same. Similarly, even though I am saying whatever you are seeing on the CRO is my audio signal, this is the equivalent signal. What is that one? Equivalent signal. Means by using this 6,000, I can get the gold, 1 gram gold. Again that 1 gram gold I can convert to 6,000 rupees. Whatever the signal I am seeing on the CRO, I can again convert to audio signal if I want, voice signal. Audio signal I can convert. Again I can convert that audio signal to that electrical signal. So even though both are not same, even though the 1 gram gold and 6,000 rupees both are not same, 6,000 rupees weight is more, 1 gram gold weight is very much less. How can we say both are same? But these are equivalent. Similarly, when I am speaking, the equivalent of my audio signal is I am seeing on the CRO. That is the electrical equivalent signal. These electrical signals generally we can represent in any form. Whenever I am speaking, you can see on different forms on the CRO. Different shapes are coming on the CRO. Different types of shapes are coming on the CRO. Now my question is, if different shapes are coming on the CRO, like this, how many signals are there in this universe? How many signals are there? Infinite signals are there. Then the problem is, we have to study about the infinite signals. Our electronic circuits to subject has to deal with infinite signals. Because now we are confident that we can convert any type of signal to electrical signal if you have sensor. Am I right? So now the question is, sir, you are saying any physical signal can be converted to electrical signal. Yes, if we have the sensor. If you have mic, you can convert voice signal to electrical signal. If you have camera, you can convert light signal to electrical signal. Similarly, if we have many sensors, those sensors are converting some physical signal to electrical signal. Finally, we are receiving the electrical signal. Because these physical signals are infinite, the electrical signals we are receiving are infinite. If we want to process these infinite signals, this single semester is not enough. Then you have to study this subject for entire lifetime. Still it will not complete. Because we have to study infinite signals. But no need to worry. One person came saying that all these infinite signals can be represented with a one sinusoidal signal. He changed the entire phenomenon. His entire life he worked for this. His name is Joseph Fourier. He was a French mathematician and a French physicist. So he worked particularly in his life during the 1800 time. He particularly worked how to represent a signal. His work started with the heat. How to represent a physical signal. Then many questions came to him. While representing the signal, he tried many options. Then he gave one beautiful solution to us. 100 rupees I can represent with 100 rupee note. Am I right? And I can even represent with it 250 rupees notes. Still the denomination is 100 rupees. I can even represent with it 520 rupees. Still the denomination is same. If one person give to you 520 rupees notes, you can give him 100 rupee. We generally don't say at that time, see, I am giving 5 notes, you are giving only 1 note. We are saying both denominations are same. Similarly, 10 rupees. Finally, 5 rupees and 1 rupee. Fourier found this 1 rupee. That 1 rupee, if you have that 1 rupee, 100 rupees you can represent with the 100 coins. Similarly, 500 rupees can be represented with 500 coins. But if you ask me, sir, this 500 note and these 500 coins are same? No. The 500 coins weight is much high compared to the 500 rupees note. But both are equivalent. Both are almost same. In our general life, we do not show the differentiation. Both are equivalent to us. Fourier found this 1 rupee. That 1 rupee is sinusoidal signal. Have you ever got the doubt why we are using this sine signal or why we are using these cosine signal only? In our mathematics we are studying about it. In our 10th class we studied about this trigonometry. And even in electronics also, whenever we want to represent some carrier signal, they are representing only the sinusoidal. Don't we have any other signals? Why everywhere we are representing these sinusoidal signal only? Sinusoidal means both sine and cosine will come in the sinusoidal signal. The answer is, this is the 1 rupee. So any signal in this universe can be represented by using the sinusoidal signal. Like you can represent 10 rupees by using 1 rupee coins. Like you can represent 20 rupees by using 1 rupee coins. You can represent 100 rupees by using 100 1 rupee coins. You can represent 500 rupees by using 500 1 rupee coins. If you have those 1 rupee coin, that 1 rupee coin with you, no need to have any note with you. 500 coins I have, 500 rupees. Fourier found this 1 rupee. By using these sinusoidal signals, you can represent any signal. Sir, by using these sinusoidal signal, can I represent this triangular wave? Yes, you can represent the triangular wave. A group of sinusoidals will give the triangular wave. A group of 1 rupee coins are giving a 10 rupees note. Similarly, a group of sinusoidal signals are giving the triangular signal. Sir, can I get this square wave? Yes. A group of sinusoidals you can use for this square wave. Sir, can I get any other signal? Example, some ramp signal or this type of signal? Yes, you can. A group of sinusoidal you have to use. So, sinusoidal signal we are taking as a fundamental signal. By using this signal, any signal can be represented. Now I am coming to my voice. This voice signal I want to see on the CRO. First I have converted this voice signal to electrical signal. When I want to see on the CRO, by using a group of sinusoidals, I can represent this voice signal. Example, in my voice I may have some range of 100 frequencies. Example, generally when I speak it will be in the range of 6 kilohertz only maximum. Okay, your audio range is 20 Hz to 20 kilohertz. I am speaking generally in the range of the 6 kilohertz range only, the range of frequencies. But all these range of frequencies can be represented by using the sinusoidal signal. That's why when some voltage is coming to our home, we will represent with sinusoidal signal. Whether we are getting voltage or current to our home, voltage, then why we are saying current bill, we have to say voltage bill, na? Whether we are getting AC voltage or DC voltage, we are getting AC voltage. Who invented AC? Nikola Tesla. Nikola Tesla invented the AC. Do you know the story of the AC invention? Thomas Alva Edison was the scientist who working there for the electronics with the DC supply. Then Nikola Tesla came for his interview and Thomas Alva Edison asked, why I have to recruit you? Then Nikola Tesla told, sir, there are only two great brains in the electronics in the world as of now. In present world only there are two great electronic brains. One is sitting in front of me and another one is sitting in front of you. That was the answer given by Nikola Tesla. Then by listening to that answer, Thomas Alva Edison got surprised, and by recognizing his confidence in his subject, he recruited him in the Edison laboratory. Then Tesla was a very genius scientist. He never worked with a confined environment because his life itself was creative. Even while now we are using the Tesla cars, which the principle he discovered much ahead. So Tesla always wanted to work with the induction principles. So Nikola Tesla, he had an idea of why can't we use an alternating current? That was a new idea. He showed the design to Thomas Alva Edison. At that time, only DC supply was there, DC current was there. They are carrying the batteries. Imagine the situation. In your home, you are carrying the batteries. Once the battery is over, again you are taking the battery to the shop for the electric current. Now we don't have such situation. So Tesla came with an idea, alternating current. Of course, the induction motor, the fan, you are seeing, whenever you see the fan, you have to remember the Tesla. He was the induction motor was the brainchild of Nikola Tesla. So when Tesla came with the alternating current, by seeing this, Edison told, it will not work. It will not work. Then Tesla had an intuition. If we supply the AC voltage, then we can supply to the long distances. It is difficult to transfer the batteries from here to long distances. But AC voltage can be transferred to the long distances. Then he separated from the Edison. Then he tried for the new way to introduce the alternating current, AC voltage to introduce. He tried different ways. And he faced some, even the court cases also. And the people argued that transformers near to the home, these are dangerous, these are like explosives. Now we are living with the transformers near to our homes. But at that time that was new. So everybody opposed Nikola Tesla. Then at the end of his life, in his final interview, Nikola Tesla told, the persons who ever opposed me, in their laboratories, they are using now the alternating current, AC voltage. That is the success for me. Means he said, the persons who even oppose, in their laboratories also now they are using AC. Now you can see, we are using the AC in the entire world because of the invention from Nikola Tesla. Okay, so we are getting the AC voltage to our home. How much voltage we are getting to our home? 230 volts RMS. If we measure with the multimeter, that voltage is 230 volts. But peak to peak voltage is not 230 volts. root mean square value is 230 volts. Okay, means if we see here, now if I ask what is the value of this, on x-axis we have the voltage, on y-axis we have the time 0 to 1 seconds. Now I asked what is the voltage of it, but its voltage is changing, am I right? At some time its voltage is 5 volts, at some time 4 volts, at some time 3 volts, like that. 0 to 1, how many times it is changing? Infinite times. Infinite times. So 0 to 1 second it is changing continuously. That's why we are calling this as a continuous signal. Now, in order to calculate the voltage, we can only say the peak value is 5 volts. Peak to peak is 10 volts. Okay, anyway, root mean square value is 230 volts we are getting to our home. This is the voltage we are getting. This voltage we are representing with the sinusoidal signal. Why? Because already Fourier told any signal can be represented by using the sinusoidal signal. We are representing even our electrical voltage signal also in the form of the sinusoidal. But my question was unanswered. Why we are saying current bill but not voltage bill? We are getting the voltage, you only told AC voltage we are getting, but we are not getting current, AC current. But why we are saying current bill but not voltage bill? Okay, let me answer this question in the simple way. Now you tell me, the motor is working in a home. We are using 3 devices. One is simple bulb, second one is motor, and the third one is fan. So out of these 3, this motor we are using for the pumping water. Out of these 3, which device is taking the more current? Motor, obviously. This is the first device which is taking more current. Next, second, fan. Third one is, but my question is, which device is taking the more voltage? Which device is taking the more voltage? Huh? All 3 devices we are giving the same voltage. Whether to the bulb, or to the fan, or to the motor, we are giving the same voltage. And we are getting that voltage always. When we connect a device, then only circuit is closed, then only we will get the current. Now the voltage is coming to your plug board, am I right? But when you connect your charger only, current is observed. Then only current reading will be changing, am I right? So current, we are giving the bill to the current because we are getting voltage always to the board. If we have to give the voltage bill, even if you consume or do not consume, same bill will come. Because each minute, each second we are getting the same voltage to the board. Am I right? But what is changing? The amount of current you are drawing from that changing. Am I right? If you connect the motor, you are drawing more current. If you connect the fan, little bit less current. If you connect the bulb, little bit more less current. That's why we are giving the bill to the current, but not to voltage. Assume if we would have got the current, instead of voltage, at that time we will give the same current to all devices, but what will be the bill? Voltage bill. But to our homes, now we get voltage only, so there is no question of voltage bill. Current bill only, it varies how much current we are drawing from that. Okay, with that simple question, then again we will come back to our topic. We will discuss about the wave shaping circuits in our first chapter. We are taking one type of a wave, sound waves you are receiving now, or light waves. Light itself it is a wave, electromagnetic wave. So the first chapter name is wave shaping circuits. There we do not discuss about the light waves or sound waves. We discuss about the electrical waves. Why? Just now we discussed any physical signal can be converted to electrical signal. Now we are dealing with those electrical signal. Now we are shaping those electrical signal. We want that signal should be in our control. So in this electronic circuits, after the chapter 1, you are capable of controlling that signal.